The equilibrium constant K tells us something. It's a numerical value. If it's very, very large, for example, I don't know, 3 times 10 to the fifth, what that tells us is the reaction goes nearly to completion. If it's very small, the forward reaction barely happens. But sometimes a reaction barely happening can still be significant if it releases something like hydrogen ions, which make it acidic, or if it releases something like lead ions, which make it toxic to an ecosystem. Generally speaking, if K is greater than 1, since we're talking about a ratio of products to reactants, if it's greater than 1, we say it favors products. If it's less than 1, we say it favors reactants. And when I refer to products and reactants, I'm referring to the forward reaction. All right, K is affected by changes in temperature, but it's different for an endothermic and an exothermic reaction. We'll talk about it more when we do Le Chatelier's principle next time, but generally speaking, and these will be rules that you can count on, if it's endothermic and I increase the temperature, we will get an increase in the K value. If I decrease the temperature, we will decrease the K value. If it's exothermic and I increase the temperature, the opposite happens in both cases. Make a note of that. We'll talk about it more next class.